Well, now let's take a look at part C here. Suppose that you took a sample of 220 products. You found that 10% of them were actually defective. Would that be an unusually high value for P? For P hat, if I have a sample size of 220? Well, again, I can start to draw out a picture to get a sense of what's actually happening here. I can see that I have a normal distribution for my P hats. I know that 5% is typical, and that I have a standard deviation given by this large, complicated square root value, 0.95 over my 220. Now, if I actually went out and I got a sample and I found 10% of the items were defective, that is above average. But the question is, again, is that unusually high? Remember, we would say something is unusual if it has a likelihood of occurring under 5%. And so in this case, we want to know ultimately, is this kind of value of 10% in the top edge of the distribution? So we would be interested in measuring again above it. If we had a value that was too low, we would be interested in measuring below it. So what we're going to be calculating here is just what is the probability that I get a p hat that is greater than 10%. Again, I know I can calculate that with a normal CDF. I just have to start at 10%, go to 1E99, go to my average of 0.05, and my standard deviation, which is my 0.05 times my 0.95 over 220. Now, if I type all of that into the calculator and I crunch this all the way out, what I'd be able to see is that I get a value again of 0.0003. So is getting 10% of the items defective, is that unusual? Is that rare? And we would ultimately be able to say, well, definitely yes, this is rare, or you could say it is unusual, right? It's got an under 5% chance of occurring. And this then allows us again to take probabilities like this and to start to make some determinations, to start to make some inferences about what's happening in the real world. Remember, we talked about this in the last section. Whenever you experience something that is weird, something that's rare, unusual, out of the ordinary, you start to look for explanations. Weird things don't happen very often, so if we think we've seen something weird, we often try to find an explanation for it. So, we want to ask the following. If in part C we experienced a very unusual result, what might this result lead us to believe about the company's claim that only 5% of their products are defective? Notice, if only 5% of the company's products are defective, then the chances of getting what we got in our sample should have just been astronomically low, right? I mean, not even 1%, not even 0.1%, right? This is equivalent to 0.03%. That's like super, super small. So again, when we experience something unusual, we start to look for explanations. So we could say here that we may believe that the company's claim is incorrect, and ultimately, it would make maybe more sense if that value of 5% was maybe a bit higher. Because let's say the average was like 9%. Well, then 10% wouldn't be weird anymore. And it wouldn't be weird that then that happened to us. So I might be able to say here that we suspect that the percentage of defective units is higher than 5%. Now again, I'm not saying that we know that for sure. All I'm saying is because I experienced something really weird, I would definitely have reason to believe or to suspect that this may actually not be a appropriate value. That maybe the company's claimed value is accidentally off. Maybe it's intentionally off. Maybe they're trying to sell themselves as looking better. But I can use probabilities to help me kind of measure this rarity so I can get a sense of how weird what I saw actually is. So hopefully these questions here seem very much in line with the types of questions we answered and asked in the last section. Now again, I'm going to have one final example here, which is example number 3, and I'm not going to go through and do that here in the video. I'm going to ask you to try to go through and answer this question on your own. This is what we would have done if we had been in class together. And so you can go ahead and try to work this problem on your own for practice. And remember, you can check the solutions for this up online in the Blackboard calendar in the notes for this particular section. Of course, if you have questions, let me know. And even after you finish this problem and you get your questions answered, make sure you're spending time to go back and take a look at those worksheet questions so you can be sure that you are unbelievably prepared for Exam 2. Exam 2 can be the hardest exam, but it also can sometimes be the easiest exam. It kind of falls to one of those extremes for most students. And the best way to turn it into your easiest exam is to be very, very, very well practiced. If you can do that and you can tell the difference between these different types of distributions, the questions that they're asking, then you should be able to address all sorts of problems like the ones that we've seen on both the front side and the back side of the formula sheet.